16, comma 3. This one will look pretty circular, actually.
Mine looks like a square.
I'm pretty bad at drawing.
I'm doing terribly.
You did better than me.
Wow.
What?
Let's zoom in and take a
Why
look
are you
at that
doing
beautiful mess.
Wow, that's some crap. Okay, this
Wow.
part here is too horrible to live.
Oh my god, look at that. Oh my god.
Spell that.
Yes. Yes, sir.
Ew.
You have a running
Wow, you're making me feel better, Parker.
This is
square.
Yeah.
Okay. Major axis,
Now let's find the foci.
minor axis. Okay, now the foci, in this case, if I call this A and this B, the foci will be c squared equals b squared minus a squared. So c squared is going to equal,
196 minus 144.
which equals?
Something.
It's not a Pythagorean triple.
2, 5, 52.
48.
52.
52. Wow.
You're off.
C squared equals 52. So C is the square root of 52, which happens to be the square root of 4 times 13. So that is 2 root 13. The square root of 13 is in between 9 and 16. 13 is between 9 and 16. So the square root of 13 is somewhere between 3 and 4. So this is somewhere between 6 and 8.
Plus 3 on... Don't you have to add 3 to that number?
Then I gotta double it.
Because it's so 2 root 13. It's not, so could we
No, but when you graph it, don't you have to add 3 to that number? Because
Oh yeah, well I've got to start from here. Oh, I see what you're saying. Yes, Ramsey's right. I have to start from my center, and I have to go 2 root 13, which is going to be 7-ish, from my negative 4, and I have to go up and down. So I have to go for my 3. I have to go up my axis. So I have to go up here to around 10. And this is the point, negative 4, comma. This is fun to write without a calculator. 3 plus 2 root 13. That's one of my foci.
Beautiful.
Isn't that fun? And then from here I've got to go down about 7, so that's somewhere around negative 4. But I don't know exactly where without a calculator, so this is the point, negative 4, comma, 3 minus 2 root 13.
These things suck.
You like where those foci are? I've written my answer perfectly and I've estimated their position well. I've drawn a horrible ellipse. As usual, if I'm grading you, with or without a calculator, when I'm looking at your graph, if your drawing is perfect, I will grade it as perfect. If your drawing is not perfect, you would better have very carefully labeled on an ellipse this point, this point, this point, this point, your center, and your foci. Make sure they're labeled so I know what you intended. I will be very kind on grading your art if it's well labeled. If it's not labeled, it better be a fantastic drawing
If
where
it's
I can look
color-coded?
at it and I know exactly where that is.
What if I color-coded it?
That'd be interesting.
What if
Okay.
it's perfectly wrong?
What if it's perfectly wrong? What if it's gorgeous but everything's off?
Yeah.
I rarely encounter that, but if I do, I'll have to get creative with the partial credit. All right. One more example I want to hit you with, and it's completing the square. Completing the square. Do you guys remember how I said yesterday that gravity is always represented by something that looks like a parabola? And that if you have both the x and the y squared, you're dealing with something that's following a path that has more than one gravity source yanking it around.
That's hyperbola.
That's either a hyperbola or an ellipse.
Hyperbolus.
Hyperbolipse.
Hyperbolate.
What if you're handed... Here's the standard... That's actually not called standard form.
Standard form.
Okay, because the standard form of an ellipse is that way. I'm just going to do this as an example.
And this is completing the square?
It will involve completing the square. What if I just hand you the equation 9x squared plus 4y squared minus 18x plus 16y minus 11 equals 0. These are ones I don't make up off the top of my head.
I would contemplate hitting you.
Oh, when do we get to rotate
you
ones next week?
divide and then you rearrange and then you slice it because you have
You
Yep.
you take out like terms,
They
kind
got
of.
like terms. So here's what I'm going to do. First off, I know I'm dealing with some type of conic. I know I'm dealing with a
Megan will never.
parabola, hyperbola, or ellipse because, stop, all I see are x squareds and y squareds. I don't see any exponents that are fractional. I don't see any roots. There's a couple things you could look for. We'll go over that a little later. For now, I'll go and tell you this is an ellipse. Next week, we'll talk about how to look at one of these and go,
Yeah,
oh,
we did this like general form.
general form. That's what I was blanking on a minute ago. So how to look at it and say, oh, I know it's an ellipse. I know it's a parabola. I know it's whatever from starting. First thing, get all the x's and y's together. Plus 4y squared plus 16y. And then take your constant term and move it to the other side. Make it a loner.
That's my jam.
Yeah, thanks. Anyway, okay, so
Database has been
this
updated.
equals 11. I've moved the 11 to the other side. Any questions, and have I rearranged it correctly? Now, the next thing you want to do before you complete the square is pull out any common factors. So I'm going to pull a 9 out of each of these. The reason we do this is that completing the square doesn't actually work unless there's a coefficient of 1 here. Okay? You need to have a coefficient of 1 in front of the x squared and the y squared for completing the square to work. So you have to pull out the 9 and the 4. Get the x squared and the y squared to have that coefficient of 1 in front. But you can't forget about the 9 and the 4. Most common mistake coming up. Actually, the first most common mistake is if this is minus when you pull it out, not pulling the minus out of both terms. We'll get to that with hyperbolas. So, this is x squared minus 2x. What number do I really, really wish I had here?
A 1.
A 1. Because
Or
you always
0.
take the middle coefficient, cut it in half, square it, add it to the end.
Add it to the other side.
Bingo. Now, so this is x squared minus 2x
Oh, it's not one. Plus 1.
plus 1
But you
plus 4.
don't you have to add it to the other side?
I'm going to hold off on that for 1 sec. What number do I really wish was at the end here?
4.
4. Cut the 4 in half, you get 2. Square that. Plus 4.
Dreams come true.
That's right, you can dream of having it there.
Only in this world.
And your wish is answered. Now what do I have to add to the other side?
5.
Yeah. Nope. No.
No.
Oh.
9 and 16.
Yeah.
Yes, okay. I did not actually add 1 here. It looks like I added 1, it will behave like I added 1. But this 1 is inside of parentheses and outside of parentheses. We have a times 9. So what I really did was I added 9 times 1.
25.
So this is plus 9 times 1 plus 4 times 4 to the other side.
Right, and then you divide.
Just 25.
Second, that's probably the most common mistake. Forgetting to, after you factor out the greatest common factor, forgetting to multiply it by what you got by completing the square. Now this looks something like 9
Oh, it's x minus 1.
times x minus 1 squared
Yeah.
plus 4